Okay, so it's our plan. Okay, guys, shall we start? Tullio, take a seat. Yeah, so it's our pleasure. Jesse wins the award for the guy coming from the farthest place. So he came from California, or it is, or maybe it's just the email. You were here, right? And he will present us. He will bring Linux to the Mars, maybe, and hopefully back.
Thanks, everybody. Yeah, forgive me, it's about 4 o'clock in the morning for me, which means my peak time for programming, but maybe not for giving presentations. Want to give everybody an introduction to my company, the company I work for, SpaceX. As a bunch of people that use Linux, I'm assuming that many of you have heard of us. Want to give you an idea of what we're doing, what the company is all about, totally non-technical presentation, and how we use Linux, and especially why we're interested in the real-time patch set. I got to start off here, unfortunately, with the legalese. SpaceX operates under something called ITAR, which is the...
Is it fine to... I mean...
Yeah, yeah, no, this is all public information.
Okay.
Yeah, so we have a really hard time sharing some of the details about exactly how we do things, because for whatever reason, rockets are classified as munitions, and the U.S. government gets freaked out about that stuff. So forgive me if you ask me a question I can't answer, not because I'm rude, it's because I don't like going to jail. But
especially during live streaming.
Yeah, during live streaming, it's going to be on record. Yeah, although, yeah, so, and even so, I couldn't even bring my own laptop. I'm using a Windows loaner laptop, so hopefully people aren't so offended that I'm using a Windows machine here at a Linux seminar. Anyway, basically what we do is we design, manufacture, and launch advanced rockets and spacecraft. We've been around for about 12 years, and we basically have two goals. We want to revolutionize access to space, and eventually, and this is the crazy one, is we want to enable people to live on other planets. This is a baby picture from the early part of the company about our first launch. It's an island out in the middle of the Pacific. This is a very small little rocket, and it's got a sandbox underneath it. Here we go, sandbox underneath it, and basically that was our very first rocket, launched a few years back. But what we build now, we're basically trying to build everything. We build the rockets. This is a giant rocket in a hangar. Rocket is closer, let's see, the first stage from here to here is 32, 34 meters. We promised to use metric on Mars, by the way. We also build the Dragon Spacecraft. This is a picture of Dragon coming up to the space station. Those are all clouds beneath it. We also build a lot of test spacecraft. This is our, what we call our Grasshopper Rocket. The whole goal is to take off, come around, and land. And we're also starting to work on actually getting people in these things, which is the total crazy part from my perspective. But we just unveiled our new Dragon Spacecraft interior a couple weeks ago, and this is a picture of enough room for 7 astronauts, and up top is a full GUI system all running Linux and providing all the interaction with the spacecraft. And just finally give everybody a perspective, and this is what I can provide. I can't really provide a whole lot of technical details, but hopefully I can provide maybe some perspective or some incentive. Basically, the company is run by Elon Musk. He's the guy that sold off his company to PayPal to start off that. He runs and builds the Tesla. He runs the Tesla company that builds the electric cars. They're starting to be sold here. But basically, his goal is to try to get the human species on 2 planets. Basically, it's a more interesting future if we've got space travel and people around in space travel. But it's also, if it turns out that we're just stuck here on the planet for the rest of humanity, it would be really, really boring, and something catastrophic could happen. So it's not cheap insurance, but it's insurance. But that's the big, grandiose way. The more fun way to say it is he'd like to die on Mars, not just at the point of impact. So that's kind of the other way to look at it. And Linux, basically we started off at the early part of the company, kind of more traditionally, with using VxWorks on our primary flight computer, and we ran Linux everywhere else on our ground stations and the computers that all ran the satellite dishes and things. And as we got more and more comfortable with Linux itself, and as the real-time patch set matured, we finally transitioned to Linux a couple years back as our primary controller for the Dragon spacecraft. I had a conversation with a bunch of guys from Sony. They basically all ganged up on me and said, "What are you guys nuts for using Linux to control a spaceship? We wrote our own operating system from scratch. What you guys should do the same." And as far as what we're concerned is it works really, really well. There are some edges around the vehicle that require some super tight control that we handle with some dedicated hardware. But for gross navigation of the vehicle, trying to get from here to there, Linux works fantastic. And now basically at this point, we use Linux for all our primary flight controls on all our vehicles, Dragon, Falcon, Grasshopper, and everything like that. And this is now where this is my most detailed technical chart here. I'm sorry about this ITAR stuff, it drives me nuts. Basically, so what we've done, and this is the view I think a lot of manufacturers have when they started using Linux in the embedded world. There's a giant block of source code for Linux. We basically chopped off and picked 10-15% of the kernel source code that we basically, specifically the drivers and schedulers that we're interested in. And then basically we have some sliver of code that lives outside the Linux source space, which is our drivers for hooking up to very specific spacecraft components. And this is the big part, and this is what's really interesting about the conference, is we basically made some small modifications to the stock Linux kernel to change. There's, as much as we'd like to believe that there's all the policy lives outside the Linux kernel, there are still some policy elements inside the Linux kernel, and you have to go in and sometimes you have to go bash on those. What's interesting is especially with the new patch set, 3.2 and beyond, a lot of that policy has been broken out, and this size of this dot is getting smaller and smaller, and especially with the scheduler, the sketch deadline, it'll be interesting to actually see how small we can get that, so we can be using stock Linux altogether. The slides are available, but I wanted to point out some free articles and some public information about Linux, our website. This Aviation Week article is pretty good, talking about how Dragon works with commodity hardware. Basically, we use all off-the-shelf hardware, not special radiation-specific hardware that they've used in previous generation spacecraft. We have some lessons learned. There's another presentation from the Embedded Linux conference 2 years ago about the using Linux on board, and there's some more details on that. What I want to show real quick, though, is if you put all this stuff together, what you get is this. So this is the Grasshopper vehicle a couple years ago. This is a video taken from a hexacopter. This vehicle is running Linux top to bottom, doing all the control. And that rocket there is that's one of the smaller ones. That's a 30-meter tall rocket, smaller. And what its job is going to do is we're trying to get it so that we can reuse these things over and over. So this is running on one engine. Falcon generally has 9 engines. This is running up to one engine. So Dragon is basically involved totally. Linux is driving the entire control loop. The bottom engine can swivel to basically keep things going, and we basically get up to basically hang out there. We hang out there at 325 meters, basically stop, and then now we're using GPS and gyroscopes. We can basically bring the system back.
Oops.
No, this is what we're supposed to be. It's just the legs are just a little on fire. Don't worry about it.
The oops in the sense. It looks like a joke, right?
Yeah.
We are launching a rocket.
Yeah.
It's not.
It's using radar for the very last bit, and then touching down exactly where it took off. So that's a 10-story tall building doing that jump that we've done, which is, it's a blast. It's fun. We've been going up to 1,000 meters, and again,
to look around.
Yeah, it's thanks to Linux we've been able to pull this stuff off, and we're super interested in basically seeing what's next for the program and for the kernel. So I just had a quick overview of what we're doing. Can I answer any questions for everybody? I'm sure people got any.
Yeah, first let me thank you for the nice thing.
I also worked in aerospace. flight control, is it certified with Linux or is it not?
So SpaceX has a business model in which we sell flights to orbit, and we basically move people's payloads. So we've worked our business model such that the certification we pick is a business necessity and not a specific necessity. So it's not a certified Linux solution, and we've got our customers comfortable with that.
Okay. Is it planned to certify your kernel according to full certifications or any?
If a customer really wants us to get that piece of paper, then we would go for it.
It's not.
It's not. No one's required it yet. It's a lot of work for a piece of paper. We better get ourselves comfortable with this in other ways.
Can you share anything on that small blob that might shrink for your modifications to the mainline?
Let's turn off this.
Yeah. Let's see. we can. I need to show that I'm actually not saying it. I can talk through kind of how we try to push things back to Linux kernel, and you can maybe figure out what's going on from there. We basically, out of this sliver of drivers, there are things that we think are secret sauce. There's very specific stuff. There are other drivers that are the new Texas Instruments temperature sensor driver that we would love to be able to push back in the mainline kernel, but because of this, we're not allowed
The
to.
modifications to mainline, you said that currently you have some modifications to the scheduler. You hope that deadline will reduce some of that.
Yeah, it's a good. Let me think about this one here.
It's all patches to GPL code, so you should be able to more or less share that.
Yes, and we're basically, since we use Linux and don't sell Linux, there's a gray area there that we're right on the edge of, admittedly. But the desire is there to really figure out how to share this information, and without the ITAR regulations, we're actually working to change that for specific parts of our vehicle to figure out how to get these information and get this knowledge back. So really want to tell you really badly, and give me a few minutes to think about it, and you and I can talk one-on-one or maybe over dinner. I can figure out a better way to answer your question, give you what you need, give you what you want.
Because I'm the Linux kernel schedule maintainer.
So I would say that it centers mostly around APIs and basically how we have I would say the ideal Linux system to play around with real time. Single user. We control every single package and program that's running. Tasks aren't created and destroyed. So being able to interact and basically set up how those processes are scheduled, launched, and monitored is really where we're mostly mucking with the kernel, trying to get the information to show that we're comfortable with the system, and then launch things in a predictable, deterministic way.
So from my point of view, I mean, closed embedded is a valid point, and it will be interesting to see how far we can provide APIs for people who want to do these things. Some of the things that simply cannot be done is user space control preemption. I know people would like to have that, and you can do that in a closed environment for general purpose operating system. That's just something you cannot ever do. So yeah, it's interesting for me to know what your desires and things are in that respect.
Yeah, I think speaking generally for the industry, there's a push and pull between making sure that everyone is contributing to something for the general case. There's also specific cases. And some of the other ideas where you basically have, you can make one CPU basically completely dedicated to a task, allows you to do
We're
stuff.
working on that.
Right.
HPC people like that,
Yep.
but real-time people like that. So yeah, that's stuff that is
So-
in progress.
Stuff like that.
Yeah. So yeah, I like to get people to tell me these things, even if they think, well, it's very specific to our use case. If enough people come up with that particular use case and think it's special for them, but don't share, then nobody knows. So I'm always trying to pull people to tell me what they're doing and why they're doing it.
Sure, and yeah, absolutely. This is not any respect a critique of shortcomings of what's the codes available. It's just trying to figure out how to push it around and tweak it for the use cases. So it's not major rip outs. I try to make the dot as small as possible.
I'd like to know how to do that.
Any other questions I can field for you? I don't want to take up everyone's time, but thank you very much.
Thank you.